We want to take the function they gave us, sine of theta is equal to 2/3. We want to take that equation and we want to use that to find the other 5 trigonometric functions. Well, one of them we can find right away is cosecant, because it's the reciprocal. So the cosecant is 3/2. Just flip that over, but we do need to find the other 4, and to find the other 4, it probably would be helpful for us to make a quick little sketch of a right triangle. So there's a right triangle. I'm going to label one of my acute angles as theta. Doesn't matter which one is which. And we know that the sine, that is the opposite side over the hypotenuse. That's the SO part of SOHCAHTOA. So I can label my triangle sides that way. Hypotenuse is across from the right angle, so the hypotenuse is going to be here. And I know the hypotenuse, based on that fraction, is 3. Across from our angle theta is the opposite side. And I know that that is 2 for this problem. And then the side remaining here, that is our adjacent side, and I don't know what the length of that side is. I do want to figure out what the length of that side is, so I'm going to use the Pythagorean theorem. If I have a triangle, a right triangle, with the Pythagorean theorem, I want to label the sides A, B, and C. C is the hypotenuse, A and B are the length of the 2 legs, doesn't matter which one is which. And our formula is a squared plus b squared equals c squared. I don't know little a in this problem. I don't know the adjacent side, but I do know b, that's the opposite side, and that has a length of 2. And I know the length of the hypotenuse, c, that has a length of 3. So from there I should be able to go through and figure out the length of side A. A is going to have a length of the square root of 5. Algebraically, it is plus or minus the square root of 5, but can't have negative side length. So I do know the adjacent side has a length of the square root of 5. We would want to simplify the square root as much as we can, but the square root of 5 does not simplify. Once you have the 3 sides, then you can go through and find the remaining trigonometric functions using SOHCAHTOA and their reciprocals. So cosine of theta, we already have sine, that's done, so I'm moving to cosine. Cosine is adjacent over hypotenuse. That fraction is simplified as much as it can be. The tangent of our angle theta, that's opposite over adjacent. That is a square root on the bottom, so I do need to rationalize that. I end up with 2 root 5 on the top, square root of 5 times square root of 5 on the bottom, which would give me just a plain old number 5. And then I want to look at those regular numbers there, the 2 and the 5 on the top and the bottom, and see if they reduce, but the fraction 2/5 does not, so that is my best answer for tangent of our angle theta. I want to take these 3 and flip them over to get our other 3 trig functions. The reciprocal of sine is the cosecant. The reciprocal of cosine is secant. So I'd want to flip this fraction over to get our secant. It does leave us with a square root in the bottom, so we would need to rationalize that. Multiplying across the top and the bottom gives us 3 root 5 over 5. Check the regular 3 and the regular 5, see if you can reduce those. They don't reduce, so that is our best answer for secant. And for cotangent, we want to take our tangent and flip that over. Remember that both of the fractions that I have here are final answer, as well as this intermediate step Both of these are the same fraction, just written in two different ways. I can flip either one over to get cotangent, and if I choose this first one, that will put the square root in the top, and then I won't have to rationalize, and that means less work for me. And that is our final answer for our five trigonometric functions that were not included in the original problem. If at the beginning of this problem they had given you one of the other trig functions, for instance, they had given you cosecant to start, flip it over to get sine, then build your triangle and do the rest of the problem from there.